Here we are going to start chapter number 2, that is polynomials. Now in this chapter we will deal with quadratic equations, which is of the general form ax square plus bx plus c with the highest degree of 2, and a constant term, and a term with a degree with an x with a degree of 1. Now let us start with question number 2. Here we have a equation. In this chapter we are going to study quadratic equation, which is of the form ax square plus bx plus c has two roots or two zeros or the two solutions, which means of any two values which we put in the equation ax square plus bx plus c equal to 0 will give the solution will give you the solution 0 on proper solution. Now here alpha and beta are such two zeros of the equation ax square plus bx plus c. The value of alpha plus beta means the value of sum of the zeros will be. Now according to the rules we have studied earlier, that if ax square plus bx plus c is equal to 0 has two roots or two zeros alpha and beta, then the sum of the roots is equals to minus b upon a, product of the roots is equals to c upon a. So according to that, the sum of the roots will be minus b upon a, which is option C. Now in question number 3, the zeros of the linear polynomial ax plus b will be we have to find the zeros of this equation ax plus b. Now what we will do, we will equate ax plus b to 0, then according to that we will find the value of x, which will come minus b upon a. So C will be the option. Now the fourth question will be the zeros of the polynomial x square minus 3 will be. Now in this question we will apply the identity of ax square minus b square, in which a becomes x and b becomes under root 3. So according to that, the roots will be the roots of this equation will be plus or minus under root 3. Now on question number 5, zeros of the polynomial x square plus 7x plus 10 will be. Here we have to use splitting the middle term. We have to split 7x in such a way that it will be multiple of 10. So such breaking of 7 will be 5 and 2. We will rewrite the equation x square plus 7x plus 10 as x square plus 5x plus 2x plus 10. Now from x square plus 5x we will take common as x, and from 2x plus 10 we will take common as plus 5. So the two roots will be minus 2 and minus 5. Power of the polynomial, the highest power of this polynomial. For this we have to into the first bracket into second bracket. When we into first bracket into second bracket, we will come across that the highest power of this equation of question number 6 will be 5. So the power of the highest power of the question number 6, the answer will be 5D. Question number 7, if zeros of the quadratic polynomial is minus 3 and 4, then quadratic polynomial will be. Now for that we have the general formula. We have the general formula of addition of zeros and multiplication of zeros, which goes as like x square plus minus b upon a x plus alpha into beta, means that is x square plus alpha plus b x square plus alpha plus beta x plus alpha into beta, which means product of the root comes in place of c. Addition of the roots will come at the place of coefficient of x, that is b. So according to that, the solution will be a, which is x square minus x minus 12. Here the product of these two roots is 12, so it will come at the place of constant term, and in the coefficient of x, the addition of roots, that is plus 4 minus 4 plus 3, which will come as minus 1. So the equation will be a. The number of zeros of a polynomial is equal to number of intersection points in The answer is 8a. Whenever we draw a line, the line which intersect the x-axis, x-axis, the point on x-axis always represent the solution of that line or that equation. So the answer is x-axis, on x-axis. Now we have to come on question number 2, fill in the blanks. The zeros of linear polynomial is, the zeros of linear polynomial is always 1. Okay, the zeros of the linear polynomial is always 1. Product of two polynomial, 1 minute. The zeros of linear polynomial is of the form ax plus b. So the zero will be, we will equate ax plus b is equals to 0, then b in here is plus, when it go from LHS to RHS will become minus, so the equation will reduce to ax is equals to minus b, then x is will give the value of minus b upon a. So the answer is minus b upon a. Product of two polynomial is always a polynomial. So the answer of second is polynomial. Sum of the zeros of the polynomial x square plus 4x plus 8. So sum of the zeros is always be minus b upon a. So in this equation, the value of b is 4 and value of a is 1. So the answer is minus 4 upon 1, which is minus 4. Product of zeros of the polynomial, which is also alpha into beta, is equals to c upon a. So in this equation, the value of c is 8 and value of a is 1. So the answer is 8 upon 1, which is 8. If one of the zeros of the polynomial k minus 1 in this equation is 3, then find the value of k. We have to put minus 3 in the equation and solve accordingly, and we will find the value of k, which is 4 by 3. We have to now jump to true or false. X square minus 2 under root x plus 7 is not a polynomial. True. Because why it is not a polynomial? Because in here the degree of middle term x under root, which is half, which is not valid. So it is true, it is not a polynomial. The degree of 0 polynomial is 0. False. The degree of 0 polynomial is 0. Actually, when a polynomial is 0, its degree is undefined, so it is false. The degree of 0 polynomial is undefined. Yeah, I have just tell you that whenever a polynomial with 0 degree, the whenever a 0 polynomial is there, its degree is undefined. So the third part is testament to that, and it is true. Now fourth point is polynomial having n degrees has maximum number of zeros. Yes, because it is the last last term, nth term is the last term of any series. So n any degree, any equation with degree n has the maximum number of roots, which is true. Now answer in one word or a question, right? Degree of linear polynomial. Degree of linear polynomial is 1. Degree of quadratic polynomial is 2. Degree of cubic polynomial is 3. Now fourth question, the grapher polynomial y is equals to px given in the figure, find the number of zeros. Here the curve cutting x-axis 2 times. So the solution of this curve or this equation which is forming this curve is 2. So the number of solution of this curve will be 2, because it is cutting x-axis at two distinct different points. Question number 5th, find the quadratic polynomial whose sum and product of given are given. So what we have to do is, first we have to find a, then b, then c, and according we have to rearrange and find the question. So in here the sum of roots is given as 1 by 4 and product is given as minus 1. So we know that alpha plus beta is equals to minus b upon a. From that uh, your your minus b upon a and c upon a will be minus 1. So from that a will become your 4. B, comparing both the things, will come to know that a will become your 4, b will become your minus 1, and c will become your minus 4. So according to situation, the required polynomial required equation will be 4x square minus 4x minus 4. Now we will move on second page, which is question number 6. Find the quadratic equation whose sum is given, product is given. It is the pattern of solution of this question is same as the previous one. So please understand that according to that this question is also done. Now we will move to question number 7. Find the quadratic equation of polynomial whose sum and product is 1 1. Here also the pattern is same as the previous questions, so follow that. Now we will jump into question number 8. It is also same as the previous questions. Find the quadratic equation. It is also question number 5, 6, 7, 8, 9 are of same pattern. So you can listen to the thorough explanation of mine of question number 5 and apply it on 6, 7, 8. You will get the answers in 9 also. Now we will directly jump to question number 10. Find the quadratic polynomial whose sum and product are 4 and 5 respectively. This is also the same. So question number 5, 6, 7, 8, 9, 10, 5 to 10 have the same pattern of solution. You can follow the thorough explanation of question number 5 and apply it on also question number 10. Okay, now we will directly jump to question number 12. Find the zeros of the quadratic polynomial 3x square minus x minus 4 and verify the relation between the zeros and the coefficient. Now we have to verify the means we have to check the coefficients and zeros. We have to first find the zeros and then cross check them with the sum of zeros, which is alpha plus beta is equal to minus b upon a, and product of zeros, which is c upon a. So first we have to find the roots of the given equation by splitting the middle term 3x square minus x minus 4. We have to split in 1x in such a way that its product should be of 4. So now here we have to one very minor thing in this given equation 3x minus x minus 4, we have to multiply c and a, which is 4. We have to multiply 4 and 3 simultaneously. So by multiplying 4 and 3 we will get 12. So we have to break minus x in such a way that we will get the multiple of the difference or addition as 12. So we have to split minus x in such a way that we get product of 12. So according to that we will find the product we will find the break minus x in such a way that, so we will find only 2, that is 4 and 3. So the equation will be reducible to 3x square minus 4x plus 3x minus 4. Now we will take two terms 3x square minus 4x as in contention, and from these two terms we will get x as common. We will get 3x minus 4, and from 3x minus 4 we will get plus 1 as common. We will get 3x minus 4. Now x plus 1 and 3x minus 4 are our two factors of the equation 3x square minus x plus 4. Now we will equate these two factors with 0. From this we will get x values as minus 1 and 4 by 3. Now the zeros of p of x is minus 1 and 4 by 3. Here the sum of zeros, which is minus 1 plus 4 by 3 is 1 by 3, and product of 0 is minus 4 by 3. Now we have to check the relation. Here we can see that 1 by 3, which is minus b upon a. From here the value of b is coming in minus 1, which is reminiscent in the question. We will get in 3x square minus x minus 4, we will get the value of b as minus 1, which is true. Now the value of a in both the product and sum of zeros we will getting 3, which is also true, and value of c we will getting minus 4, which is also true. So this is the justification. Now in question number 13 and 14 we have to use exact pattern for solution. So please go through the thorough explanation of mine in explaining the question number 12. Thank you. This is your chapter 12.